So last thing we were doing the centripetal acceleration. Perfect. So let's see. So how are we going to use this actually centripetal acceleration? Like I said, if you are going in a circle, there has to be an acceleration, and we proved it. And this acceleration has to be provided by a force. That was what we defined last time. So just to give an example, let's say if you have a block here, M, and if this is going in a circle, let's say this is going with speed v. So when I draw the free body diagram, this is what I will do. See, free body diagram will have forces tension, we'll have normal reaction, we have mg. Any other force? That's it. There are no other forces. Now we will say, since this is going in a circle, since it goes in a circle, there has to be an acceleration. If the acceleration is not there, it won't go in a circle. And how much is that? So A centripetal is u square by r. Done. Then step 2, resolve the forces and write the equations. In the horizontal direction, we have tension is equal to mass into acceleration. So tension will be m into u square by r. There. Is that clear, everyone? That's it. So this thing, what it gives you is an acceleration, and then it is as usual. Draw an FBD equation and solve. Now, what is centrifugal force? Forget about it. Right now, you don't know anything about it. I will teach you that. But till then, the only thing you know is this. If someone goes in a circle, there has to be an acceleration. Clear? Let's see a question based on this. So if you go back to the steps, step 1, choose your system, draw the FBD. Step 2, assign accelerations. Now in that thing, you will say, if you go in a circle, there will be u square by r, that is additional. Step 3, resolve forces along x and y. Step 4, write equations and solve. Everything is same, only thing is this. So let's see our question. Top view. We have a rod here. This is fixed. We have a mass here, m. We have one more mass here, 2m, and we have one more mass here, 3m. Getting it? And this whole setup is rotating with omega. Matlab, they're going like this. Are you able to visualize how it is? Meaning, if you see this thing, what I'm holding now, so it is rotating like this. So there is one particle here, one here, and one here, and the whole thing is rotating. Think of like this. When you have gone to the barbecue nation, you must have seen that rod, there are paneer ka pieces. Able to visualize? So that skewer, when they do that, the paneer ka pieces, they keep 3 paneer ka pieces or something. So it's like that. There are 3 pieces. This whole setup is rotating with omega. So we have a light rod. Right, with 3 particles. Rotates on a smooth horizontal floor. As shown. Now, if you look at this rod, this part of the rod will have tension T1, this part will have T2, this part will have T3. So each section of the rod will have different tensions. So there's no gravity, nothing here. So find T1 is to T2 is to T3. Is the diagram clear? What I'm asking everyone? So it's like that stick with 3 paneer pieces. You're holding one side and you're rotating the whole thing. I think when I said paneer, that must have clicked immediately. So, yeah. Devansh is feeling, sir, now I want to eat.
Sir, in this, won't we need to know the ratio of the radius?
वो भी लगेगा. I thought for a moment you're going to ask, sir, when will you take for us paneer? ठीक है, and this was L, this was L, this was L. All are equal lengths. You'll be having a get together next year. I'll be inviting all your seniors who have been in IITs and who are writing this exam this year and will get results. You guys can talk to them and interact them. We will be doing that somewhere in June. Then you can eat. And then when you write your exam, then for your farewell also you'll meet again. I think this year when we did, we had almost 92 kids. IIT Bombay's only 19 people came. Your seniors keep coming. Even that 5 years ka your seniors keep coming. People are passing out. So that is one privilege. If you get into IIT, you get invited every year. You get free food every year. How do we do this? Should I help you with one? See, I'll show you one. So step one, choose your system, draw the FPD. I will take 3M. So on 3M, the forces are tension, T3. That's it. That is the only force which is there in the horizontal direction. Then, since you're going in a circle, there must be an acceleration, which is omega square r, omega square, and the radius is 3r. Therefore, T3 is equal to mass into acceleration, which is 3m into omega square 3r. That is 9 omega square r. Make sense? Next thing, choose your system 2m. Now, what are the forces acting? There is one tension is pulling inside, rods always pull, and this tension is pulling it outside. And you are going in a circle. Since you are going in a circle, there will be an acceleration. How much? Omega square r. Omega square radius is 2r. Why am I not using v square? Omega is given, so use omega. If v is given, then use v. Now, force equation, tension T2 minus T3, that is your net force, is equal to mass is 2m into acceleration. But T3 is already 9 omega square. That is T3 plus 4m omega square. That is 9 plus 4, 13m omega square r. Next thing, I will choose my system as m. On m, there are two forces. T1 is pulling inside, T2 is pulling outside. Remember, every particle, right? M1 and M and 2m will have two rods. You are going in a circle. Since you are going in a circle, there will be an acceleration, which is omega square into radius, which is r. Then this force will be T1 minus T2 is equal to m omega ma. But T2 is already 13, so T1 will be 14 m omega square r. So from here we can see ratio T1 is to T2 is to T3 will be 14 is to 13 is to 9. Please check the steps. There, the only new thing you learned is since you go in a circle, there will be an acceleration. That's it. That is the only extra argument you'll keep making every time. Any doubts on this, please ask me. Sure, everyone? Once you write that acceleration, everything looks like NLM only, right? Let's see one more. Turning the page. We have a pendulum here. This is called conical pendulum. This is going in a circle like this. This is called horizontal circle. Basically, it's going in a horizontal circle. Are you able to visualize how it is? It is like this. If you just look at the tip of this pen, it's like going like this. Hope you're able to visualize. It's going like this. So this thing is not going up and down. It is just going in one plane. Mass is m, length is L, this angle is theta. It is going in a circle. There is no information about speed. So this is called as a conical pendulum. So if someone says, a conical pendulum, this is what they're talking about. Or someone says a pendulum is going in a horizontal circle. This is what they mean. So they won't give you the diagram. They will simply say like this, a conical pendulum, or a pendulum is going in a horizontal circle. So this is there. So the question is, a pendulum rotates in a horizontal circle as shown. Find tension and the time period for one revolution. Pendulum rotates in a horizontal circle. Find tension and time period for one revolution. Same thing. Step 1, choose a system, draw the FBD. Step 2, assign acceleration. Step 3, write equation. Step 4, solve. The game is still the same. mg sec theta. Okay. Find the time period also. Let's see. So step one, choose your system. There's only one particle, there's nothing to choose. Draw your FPD, the forces would be tension, mg. Any other force? There are no other forces. Step two, SN accelerations. Since you're going in a circle, there will be an acceleration toward the center. How much? V square by R. What is R? This is your R. How much is that? L sine theta. Then resolve the forces. This is theta. This would be T cos theta. This would be T sine theta. This would be mg. And this would be acceleration V square by R. So in the vertical direction, there is no other acceleration. To T cos theta minus mg is 0. So we get tension is mg by cos theta. So in the horizontal direction, T sine theta is the one who is providing the acceleration. So who is the centripetal force here? T sine theta is the centripetal force. Are you getting it? So T sine theta is m into AC, but T is already mg cos theta. So that is mg tan theta. This is m into V square by R. R is nothing but L sine theta. So m cancels, you get V square is equal to Lg tan theta sine theta. So you got the speed from here. What I want is time, isn't it? So time will be the circumference 2 pi r by speed v. Make sense? The total circumference by speed. So that would be 2 pi r is L sine theta. Speed is the root Lg tan theta sine theta. So this would be 2 pi root over L by g. That will become sine square theta. One sine will cancel, you're left with cos theta. That's your answer. Yeah, next one. Next one. Any doubt so far? Cos theta नीचे आएगा ऊपर आएगा रे? ऊपर आएगा. Hmm. 14 to 1. Death well. Or also called as death rotor. No one dies, don't worry. So we have a cylinder here. This is radius r. And this whole setup is rotating with omega. This is a rough rotating cylinder. So here you're going inside and you're standing inside here. Your mass is m and the friction is mu. So now what happens when the cylinder is rotating, you basically stick to the wall. So, and here niche there's an open end, okay? There's nothing there to support you actually. The person is placed in a rough cylinder. with his back touching the walls. Find omega if he does not slip. So when this thing rotates with a certain omega, he won't slip. If you rotate too slow, you will slide. Did you see that thing? The recent viral हो गया ना वो video वो Hanuman kind करके there is a song. He sings that song na ho ha करके. So in that if you see these people are with the bikes they're going round. So in this case I am rotating the cylinder. In that case people are rotating. End of the day the result is the same. This is actually a ride in an amusement park. It looks like where is this? This one.
Is it a weight balancing thing?
Yeah.
Okay.
Okay, everyone, just keep your heels back and head flat against the wall.
Yeah, I'll
Maintain an
So
upright
that we got a
position.
cylinder there, big one, and
You feel
there
scared
all kids
or
are
sick, just
touching the wall.
Stop, and I'll stop the ride. And here we go.
And now
Hang
they
on.
start
Legs
rotating
back.
the whole thing.
Sorry, Will. It's alright. Legs apart. Oh, it's alright.
The right side, the kid with the glasses is Saya, the small one. It is rotating. It has reached certain speed. Now look at the floor. Huh? So once you reach a certain speed, the floor just goes down. There. You can see, and look at the kid on the left side. Huh? She left her hands and doing this. So this is what I was saying. Remember, in friction is independent of surface area. Whether the kid is touching the wall only with little area or more area, it doesn't matter. Friction will act the same amount. And you can see the kids are literally in air. They're just stuck to the wall. The kid is scared. Now see, he tries to go, but he still doesn't fall. Did you see? That's what I said. Independent of surface area. It doesn't matter.
It's alright, you okay?
No, he's not okay. He's crying.
It's alright. It's alright, you okay?
So now they slow it down. Like I said, now if you decrease omega, something happens. You don't have enough friction, and then you start sliding down.
It's alright. It's alright.
Stay flat against the wall until the
Clear? So that is the question. So with what speed should you rotate the cylinder to save Isaiah? Let's get this. I hope the diagram is clear now. Again, don't worry about the question. Step 1, choose a system, draw the FBD. Step 2, SN acceleration. Step 3, solve. Mu mg by r. M नहीं आएगा रे विहान. Told mu gr. Okay, let's see. See. Step 1, choose your system. Man is your system. Write the forces. mg is downward. Friction is balancing you. Normal reaction. Any other force? There are no other force. You are going in a circle. Since you go in a circle, there will be a centripetal acceleration, AC, which is omega square r. So normal reaction is m omega square. So who is the centripetal force here? Normal reaction. So here n is the centripetal force. And be careful, don't write n is equal to mg every time. And then friction is equal to mg. But we know friction value is always less than equal to mu into n. So mg is less than equal to mu m omega square r. Therefore, omega must be greater than equal to root over g by mu r. Check. This is the minimum speed. If you go at least with this much speed, you are safe. Anything more is also fine. बस यही करना था. Check.
Sir, he was on the inside of the cylinder. Sir, was the man on the inside of the cylinder?
Next one. Now, so this, I hope everyone got the meaning of centripetal acceleration. So what is the centrifugal force which we keep talking about? Like you must have keep hearing about it. So centrifugal force so in certain cases, it is convenient to solve the problem with respect to the rotating frame. That means sometimes it becomes easy to stand in that rotating frame and see the problem. It is convenient to solve with respect to the rotating frame. But then the problem is, if you go and stand on the rotating frame, just now we proved anything that goes in a circle has acceleration. Since rotating frames have acceleration, it's a non-inertial frame. And if it's a non-inertial frame, therefore we have to apply pseudo force. In order to use laws of motion. This pseudo force is called a centrifugal force. That's what doesn't exist. So, for example, again, I hope you remember what is pseudo force. Pseudo force is nothing but mass of the body being observed into negative of acceleration of the observer. So, look at this example. So when we did this question, right, block M, it was a string and this was going in a circle. And we said it is going with you. So now if you ask this thing to be solved by two people, let's say we have A on the ground and you make one more guy sit on the block B. Now if you ask A and B to solve the problem, A will say, okay, I see a block. There is a tension. There is a normal reaction. There is an mg. And since it is going in a circle, there will be a centripetal acceleration u square by r. And when you tell him to write the equation, he will say, okay, so he will say tension is equal to mass into acceleration, which is mu square by r. But if you ask B to solve the problem, B will say there is a body, mass m, tension, normal reaction, mg. Since I'm standing in a non-inertial frame, I'm accelerating, I have to apply a pseudo force, which is m into A, the pseudo force, which is mu square by r. And since I'm standing on B, I will think this is at rest, isn't it? B thinks block is at rest. If you're standing on the block, you think it is not moving. And he will say tension minus mu square by r, the pseudo force, is mass into acceleration is 0. Therefore, he will say tension is equal to mu square by r. End of the day, you get the same answer. So the thing is, should I use centripetal acceleration? Should I use centrifugal force? It is your choice. You have to ask yourself, where is my observer? If you say my observer is on the ground, don't talk about centrifugal force. If you say my observer is on the body, don't talk about centripetal acceleration. You can have only one of them. You can't have both at the same time. You're getting it? You are talking about the same thing in two different frames. Either you have centripetal acceleration or you have centrifugal force. You don't have both in the same free body diagram. Is that sentence making sense? It's like, imagine you have 1 lakh rupees in your bank account and you write a check for 1 lakh rupees. How much money you have total? 1 lakh only, right? If you use the check, there'll be no money in the account. If you want money in the account, don't use the check. You don't have 2 lakhs. If someone thinks you have 2 lakhs, you found out a way to double your money instantaneously. You'll be pretty rich pretty soon. Is this page making sense? Huh, Puroja? Sure? Confused? Any confusion? Arnav? Daksha? Jainil? Ojas? Vignajit? And let me take one more example. So let's see some questions based on this. So what will I do? I will solve few problems with both the methods. We will see in the ground frame, we will do this thing. So if I have to write the steps, this is what I will do. Steps to solve. Step 1, choose your observer. So you need to ask yourself, where is the observer? So if observer is on ground, use centripetal acceleration. Don't even mention the word centrifugal force. You just apply FBD and solve. If the observer is on the rotating frame, use centrifugal force. Don't mention centripetal acceleration. You can't have both at the same time. The moment you choose one, other you have to leave it. Step 2, draw FBD. Assign accelerations. So even in non-inertial terms, sometimes the bodies will move. You can assign accelerations. Then use constraints. This thing will be exactly again our Newton's law. Resolve forces along x and y. Solve. So the only new thing is the first part. Step 2, 3, 4 are the same thing. Have a look at this page. Clear? Let's see. Let's see a question. So again, centrifugal force, right? If you ask what is centrifugal force, everyone says mu square by r. It depends. So let's see this problem. You'll get the understanding what's happening. So we have a disk, rough, horizontal, rotating disk. Radius of the disk is r. On this disk, you kept a coin at a distance smaller. This is a coin of mass m. Quotient of friction is mu. This setup is rotating with omega. Okay. Now, this is where the question gets messed up. Let's say we have an observer here, A, we have an observer here, B, on the coin, and we have an observer here, C, on the other side of the thing, along the diameter. Getting it? 3 observers are there. Find omega so that the coin does not slip. Second, find the centrifugal force as seen by ABC. So you try. What I will try to do, we will try to solve the problem in these 3 people ka frame. If A solves the problem, B solves the problem, and C solves the problem, let's see how will the FBDs and accelerations look like. But end of the day, answer will come same, but the way they look will be different. Especially the centrifugal force part is important. Most people have that misconception centrifugal force is mu square by r. That is not mu square by r, is not centrifugal force. We will see. Try. I'll give 2-3 minutes. Just give it a try. I'll be back in a minute. Let's see.
Sir, is C also on the disk?
Show you. Root mu G by R. Let's see. Listen, let's try to solve from the 3 people ka frame. So first thing, let's define the accelerations. Okay, what is the acceleration of A? 0, because he's at rest. Agreed. What is the acceleration of B? Acceleration of B is towards the center, which is omega square small r. What is the acceleration of C? Acceleration of C is towards the center, which is omega square capital R. Are these accelerations clear? Because if you go in a circle, there will be an acceleration omega square r. Yeah, C is sitting on the disk. C is on the circumference of disk. And B is on the coin. Okay. Now, first let's ask A to solve the problem. So A will say, fair enough. There is a coin. There is a normal reaction. There is an mg. Now the general doubt is, how is the friction? Think about it. He will say, since it is going in a circle, there should be an acceleration, which is omega square smaller. Now tell me one thing, horizontally, is there any force who can provide this? There's only one person. Who? Friction. So friction is the one actually providing the centripetal force here. There's no other force. Friction is the only one who's making sure it can't slip outside. You know how is this? Did you ever try this thing? On your fan, you keep a duster here and switch on the fan. Ever did this in school? Never did such kind of things. Why are you guys so good, Ray? We used to do this thing. We used to put the thing, duster on top of the fan and leave it there. Whoever comes and switches on the fan, this will rotate, and this thing used to go and fall on someone. Never did that. So that is that. People used to do that, but I never used to do such things. I thought used to take chalk piece ka powder and take that powder and put it on the fan. So whoever goes and switches on the fan, the full powder used to fall in the room. That was a little more evil. So one day, one guy kept the duster like this. He switched on, this thing went and fell on the teacher. So this thing is like that. You can try this after the class. You put something on top of the fan and switch it on. This thing will just slide outside. So the one who is making you stop is the friction. And since the fan ka speed keeps increasing, eventually it will slide. So done. So when he writes the equation, he will say N is equal to mg. And the one who is providing acceleration is friction, mass into acceleration. So he will say this is m omega square small r. This is less than equal to mu n, which is mu mg. So he says omega is less than equal to mu g by r ka root. So A says, as long as you go with omega less than this, you're safe. Make sense? Now, if you ask B to solve, what will he say? B will say, we have the coin, there is an mg, there is a normal reaction, there is a friction. Since I'm standing on this, my acceleration is omega square r inside, so there will be a pseudo force m omega square small r, the pseudo force, which is actually the centrifugal force. So pseudo force only, we are calling it centrifugal force. As long as you remember that, you will start understanding stuff. And then this guy will say, this is at rest. So he will say, F minus m omega square r equal to 0. So we get F is equal to m omega square r less than equal to mu mg. You get the same answer. Omega is less than equal to mu g by r. Clear? Now the interesting thing. What will C say? See, we will never solve the problem in Seeker frame, but conceptually, if you try to see what happens, mg, normal reaction, there is a friction. Now see what happens. Now C will say, since I'm standing on a rotating frame, there is a pseudo force. The pseudo force is mass of the body into my acceleration in the opposite direction, which is this way. Isn't it? This would be mass into omega square capital R. This is the pseudo force due to C. And this is also the centrifugal force. Did you see? Centrifugal force is not towards the center, not away from the center. It is towards in this case. And the magnitude is not m omega small r, it is capital R. And story is still not over. And if you ask him what is the acceleration, he will say, look at this. He will say, my acceleration is this way and the coin acceleration is this way. So what he will see is relative acceleration. He will see a relative, which is omega square small r plus omega square capital R. Now, we will normally not solve with respect to C. This is the acceleration of the coin as seen by C. Isn't it? If you stop C, the accelerations will add up. And now when he writes the equation, he will say, so F plus the pseudo force will be mass into acceleration, which is omega square r plus omega square capital R. This and this will cancel. We get F is equal to m omega square r, which is less than equal to mu n, which is equal to mu mg. Same story, answer will again come back to mu g by r. But did you notice what happened with C? C will think the pseudo force is there, but it is toward the center, which is the centrifugal force. And C will also think the B is accelerating towards him with an acceleration of AB plus AC because it adds up. Both are opposite. So if someone asks you this question, what is the centrifugal force? It is m omega square r only if the person is standing on the coin. If the observer is standing somewhere else, your centrifugal force can change. Have a look at this. I'll show you one more example. So this is how you solve in A ka frame, B ka frame, and C ka frame. Any doubts? Anyone not convinced, confused? Please ask. Nani Harika? Clear with this? Ishana? Vihan? Ansh? Adi? Arya? Ahna? Pratik, clear na? Arnav? Nikhil? Perfect. Now, let me ask you one more based on this. This is also a good one. Let's say we have two particles going in two circles. So this is A going with UA and This radius is RA and the mass is MA. This is going with UB, mass MB. This is RB, this is particle B. So A and B go in respective circles. This can be a good question also. So find centrifugal force on the first one, A, as seen by B. So if B is the observer, what is the centrifugal force? On B, as seen by A. If A is the observer, what is the centrifugal force on B? Let's get this. You'll see the centripetal force on the coin. CE doesn't know what is centripetal force. If you say like that, if you see in Sega frame, centripetal force is friction plus this pseudo force. That whole term is your centrifugal force. You can say that way. Right, Purvaja? So Sega frame में friction plus is the pseudo force is the centripetal force. Why would C think friction acts along the pseudo force? Now see, tell me one thing. No matter in which frame you see, friction is always inwards only, right? The force direction cannot change because you're in a different frame. Isn't it? So if you're in a different frame, you get pseudo force, but the force direction can't change in your frame. Let's get this. This thing, I can put it as a question only, actually. It's a good one. It's a conceptual one. If you ask A, and these are perpendicular, okay? These are perpendicular, exactly. Zero. Why it is zero, God? Let me show you. See, again, don't get into the confusion of a centrifugal force. Just forget about it. What is centrifugal force? Pseudo force, no? So what I'm asking here is, first let's find A as seen by B. So who is the observer? B is the observer, right? If B is the observer, what to do? Stop him. So what is B ka acceleration? Since he's going in a circle, acceleration of B will be M UB square by RB. Agreed? So what is the pseudo force? Wait, my mistake. Wait, I think my mic is on mute. I can't hear you. हाँ अंश बोलो ना.
Nice, sir. That's why I had to message you.
हाँ वो actually वो before I was showing the video ना तो मेरा mute में क्या चला गया. But हाँ I couldn't hear you guys. Able to hear me now? Whenever I show you video, right, I have to keep my this thing on little low volume or else वो पूरा sound का it will become mixed. So in case you are saying something and I'm not replying, मतलब I'm on mute. So just remember that. Anyway, so हो गया. अभी देखो ना पूरा जाना. You tell me if you're standing on B and if you're looking at A and this is your acceleration, what is the pseudo force? Mass of the body you're observing. Whom are you observing? A. So uska mass and acceleration of B in the opposite direction. So that would be this direction, isn't it? Mass of A into acceleration of B, which is ma into ub square by rb. Make sense? So that is the centrifugal force, no then? And what is the direction? It is not even towards the center. Dekho, it is tangential.
So, sir, it is not compulsory that it should be towards the center.
That is because it is towards the center. It is away from the center because we generally keep the observer on the body. What if you keep the observer somewhere else? Got it? So centrifugal force on A as seen by B is mass of A, acceleration of B square by RB, and the direction is I cap. It is not towards center. Sure. Now can you do the other way around? Now same thing. If you ask centrifugal force on B as seen by A, वो क्या होगा? I hope everyone is getting what is centrifugal force. Indirectly net, it is simply a pseudo force. Oh, someone else asked the doubt again. Who asked it? You can ask again. Or if it is clear, then it is great. I answer. What was this answer? So now we are doing B as seen by A. So that means who is my observer? A is my observer. So what is A ka acceleration? A ka acceleration is this way, center, which is UA square by RA. So this pseudo force will be this way, mass of B into UA square by RA. This is your centrifugal force. Check. Just give me a minute. Someone is ringing the bell. Clear? Laundry guy. Any other doubts on this thing? Centrifugal force. So be careful. If someone asks you centrifugal force is how much, you should ask, boss, who is the observer? But in general, in books and all, what we do is we take the observer to be on the body only. In that case, it will be away from the center. Clear with this? Any doubts on this? Great. Now, in this, again, there's one more concept. Let's say, so we can just write a statement here. Centrifugal force need not be toward the center, depends on the observer. Need not be away from center. Depends on the observer. I hope, is everyone clear what is centripetal and what is centrifugal now? Great. Look at this thing. This is also another important one. So let's say we have a wedge like this, and this guy is going with V1. Inside we have a block here, M, which is going this way with V2. This is a circular track of radius R. It is a smooth track. Okay. A block M moves inside a circular track of a wedge. As shown. So here the velocities V1 and V2 are velocities in the ground frame. The person who is on the ground thinks these are the velocities. Okay. Find the centripetal acceleration and the normal reaction on the block. Let's get this. Now listen, let me tell you one thing. When you're writing the formula, A centripetal is V square by R. What is V? V tangential. Isn't it? V is the V tangential. Now tell me one thing. When this block is going like this, if a person is standing on the ground, do you think he will think this is going in a circle? Do you think this person on the ground thinks it is going in a circle? Observe करके देखो ना, next moment what will happen? This block will try to go here, but the wedge itself will go front, na? So he will think the block is going in some weird path, isn't it? The person on the ground will not think it is going in a circle. He will think it is going in some weird direction. Agreed? Now, can you tell me who thinks it is going in a circle? So, if you take the center here and if you stand here, this person will think it is going in a circle. Isn't it? So, block M moves in a circle with respect to the center of that curve, not with respect to the ground. Moves in a circle with respect to the center. Now, if you see in the ground frame, it kind of looks like this. So when the body has reached here, this will go with some velocity v1, and this wedge is going with v2. This is not a circle in any case. Like this will be going in some weird direction. This is going something like this, isn't it? So with respect to ground, it doesn't go in a circle. Now, if it is not moving in a circle, I can't use Vt square by r. So this is the answer. So remember this, very important. So when you're writing a centripetal, that v square by r, this v is the relative velocity with respect to the center. Till now, you never had a problem because the center of the circle never moved. So in our scenario, this guy will think this guy, the wedge is going with v1, this guy is going with v2. So it thinks it is going with v1 minus v2. Make sense? So v1 minus v2. So you bring this person to rest, and that is what he will think. So a centripetal will be v, sorry, both are going opposite, na? They'll add up v1 plus v2. So v1 plus v2 whole square by r. This is your centripetal acceleration, everyone. Now, if you write the FBD, this is normal, this is mg, and you are going in a circle. If you go in a circle, there will be a centripetal acceleration AC. And the force equation will be n minus mg is equal to mass into acceleration. Normal reaction will be mg plus m into v1 plus v2 whole square by r. Centripetal acceleration is not v square by r. It is, yeah, right, Vihan. It is the velocity with respect to the center. Is this clear, everyone? This is a pretty good one. Most people goof it up. They think like that v is the velocity of the body. No, v is the velocity with respect to the center. Because center is the only person who thinks it is going in a circle. Everyone else will think it is going in some weird curve. Is that statement making sense? So if you go and stand on the center, suddenly you will think the block is going with v1 plus v2. So these are some pretty important concepts. This one and the previous one, the centrifugal force one. Most people think centrifugal force mv square by r away from the center. That is one mistake. Second thing, what is centripetal acceleration? Ask them, they'll say v square by r. You tell them center is moving, so what? It does depend on the center. Any doubts on this? Please ask me. These are the kind of conceptual questions you get. Clear? And this problem, remember, you will again encounter this thing in 2 more chapters. We'll encounter this in center of mass and rotational mechanics. You want to see how it looks? It looks like this. So we have a big wedge there, we have a small ball there, it starts rolling down. And then there's here, a centripetal is v relative square by r minus r. So there, again, I wrote it here because you seniors forgot. So this will be a part of some big problem. That will be a proper advanced question. Clear with this? So do keep it in mind. Any doubts so far, please ask me. So I hope you're getting it. Circular motion is not difficult, but there are things which are different. Next one. Let's see something more easy. We have a block of mass in here. So we have 2 strings like this. Let this be theta, let this be theta, gravity is there. And this guy is going in a circle. This is going in a circle with speed v, and this radius is r. This string will have a tension T1, and this string will have tension T2. Find T1, T2. Block goes in a horizontal circle, but there are two strings connected. So step one, ask yourself, where are you standing? Centrifugal force का advantage क्या है ना? It becomes easy to visualize things in terms of force. Horizontal circle. So you can use anything. You can use centripetal acceleration or centrifugal force. Like I said, step one, define your observer. How do we do this? Draw a free body diagram. Finish it off. Let's see. Step one, choose my observer. I'll put my observer on the block. Means I'm going to use centrifugal force. Doesn't matter. You can take anything you want. So my force is T1, T2. The centrifugal force will be away from the center. So in this case, it is mv square by r, your own weight mg. So if that angle is theta, this is theta. So components will be T1 cos theta, T1 sin theta, T2 sin theta, T2 cos theta. So T1 cos theta minus T2 cos theta is mg. So we get T1 minus T2 is mg by cos theta. Horizontally, T1 sin theta plus T2 sin theta is the centrifugal force, mv square by r. That will give T1 plus T2 is equal to mv square by r sin theta. You are done. Two equations, two unknowns. Solve them. You'll get T1 and T2. Add them. You'll get T1. Subtract them. You'll get T2. So T1 would be half of mg by cos theta plus mv square by r sin theta. Yeah. Sure. And T2 you'll get automatically from there. Next one. Clear, Nikhil? Devansh? Jainil? Surya? Daksha? Got this? Next one. So we have a disk here. This is rotating with omega. On this, you kept a rope, a rod, you can say. A rod is placed like this. So the center is x is equal to 0. This is x is equal to r by 2, and this is x is equal to r. This is a rod of mass n. And the surface is rough, so there is a friction mu. This is a rough rotating disk. Find omega so that the rod doesn't slip. Find maximum omega if rod does not slip. Let's get that. So instead of a coin, I kept a rod. So in case of a coin, the centrifugal force m omega square r. But here the problem r is changing for every point, right? You have to integrate. That is the thing. When the moment you see something is changing, that should ring the alarm bells like, boss, maybe the calculus is involved. Think I'll give you 2 minutes. Try to figure it out. Try. Give it a try. Any answers? Cube root of 3 mu g ln 2. Seriously? इतना बड़ा आ गया रे? अरे लॉन नहीं आएगा, क्यूब भी नहीं आएगा. Let's see. Root mu g by r. Okay. Let's try to understand what is happening here. So on this disk, when it's rotating, there are two things happening. At every point here, there is a centrifugal forces pushing, isn't it? D omega square r. At the same time, you also have frictions which are fighting back. df. Make sense? So you have both of them. So on this rod here, at a distance x, if you take a small piece dx, let's try to see the forces on the small piece dx. There'll be a tension. There'll be a tension this side. Let this be t. Let this be t plus dt. There is also a centrifugal force dm omega square x, and there is a small friction acting on this, isn't it? On that small piece dx, these are the forces acting on it. That dt is the small change in tension because of that extra centrifugal force. We don't need it here, but I'm just trying to show you in FBD how it looks. They can ask you find tension in the rod, so then you'll need it. Then so now can I say like this? The total centrifugal force, so if you just take the full rod, all the centrifugal forces will be like this. Oops, I wrote reverse. All centrifugal forces will be away. All frictions will be inward. So I can write the total friction is equal to total centrifugal force. Can I write that? All the frictions acting on the rod must be equal to all the centrifugal forces. That means integral df. Again, remember, just like that. You can't say friction of one rod is equal to the centrifugal force of that piece. Make sense? But total will be equal because there are tensions in the middle. So this will be equal to df is equal to integral dm omega square x. So dm is the mass of this small piece, which is total mass of the rod is m, total length of the rod is r by 2, and the length is dx. Mass per unit length into the length. And what is friction here? Mu dmg. This will be dm omega square x. So bring the dm and substitute here. So this will be mu g, dm will be 2m by r dx. This will go from and this will be 2m by r omega square x dx. What are the limits? The rod is starting from r by 2 and going till r. So here we will get a 2 mu mg by integral dx r by 2 to r, and this will be 2m omega square by r integral x dx from r by 2 to r. So m r will cancel out. Let me show it on the next page. M by r will cancel out. So you'll be left out with 2 mu g is there. The 2 also will cancel out. So you'll have mu g, x limits will go from r by 2 to r. This side you will have omega square. Omega square x square by 2 limits will go from r to r by 2. So mu g r minus r by 2. This is omega square by 2, which is r square minus r square by 4. This would be mu g r by 2. This is omega square by 2, 3r square by 4. 1 2 goes off, 1 r also goes off. We get omega square 4 mu g by 3r ka root. Someone got it right, Vihan. Please check this thing. Once you got this integration, your job's done. So the main idea is remember that question which we did, on that inclined may there is a rope which is sliding, which is at rest. Same idea. All the frictions are equal to mg sine theta. Here, all the frictions are equal to the centrifugal force. Have a look at this.
Sir,
Right.
could you once explain why there is t plus dt and all? It's not clear exactly to me.
So what do you think it will be? You think tension will be same on both the sides? Do you agree if you take a small piece there will be 2 tensions on both the sides?
Yes, sir.
Is there any guarantee they'll be equal? Is there
But
any
sir-
guarantee, 100% guarantee, will they be equal?
No, sir. But
No. So there should be 2 different tensions, right? Instead of taking T1, T2, I'm taking T and T plus dt. Make sense? It is simply 2 different tensions, right? I can take any symbol I want. But mathematically, it looks more nice, na? T and T plus dt. Because of that small dx, tension increased by small dt.
so why would tension increase?
That I don't know. dt will take care of the sign.
Oh,
I
so
never
we're
said
not
it.
knowing anything. We're
dt is just a
assuming.
variable. dt can be positive or negative. dt is
But
simply
sir,
change,
dt will be
right?
there.
dt will be there. ये फर्स्ट टाइम नहीं है रेड बोर्ड. जब हम यहाँ पे भी किया था, देखो यहाँ पे भी dt लिखा था मैंने. It's not the first time it came. It will be always there. When you take a small part of the string, on both the sides, the tension has to be different. So we indicate that by saying, boss, there are 2 parts. Clear, everyone?
Sir, because it has mass.
Yeah.
Okay, sir. Thank you, sir.
All clear with us? Let's see one more. We have a block M. We have a block 2M. This is connected to a pulley. This is connected to a pulley. This is placed on the ground. And this whole setup is rotating with omega. This whole setup is rotating with omega. All surfaces are rough. So here the friction is mu. This is also mu. Find omega max if the blocks don't slip. So block is on top of another. So this thing is actually on a plate or something. I'm not showing the full diagram. It will be something like this. But the diagram is clear, na? What is happening? Basically, it would have looked something like this. Like this. And this whole plate is rotating with omega. This is how it would have looked. I'm just showing the one view. Let's get this. Radius लगेगा. Take this thing as R. Same steps. Draw a free body diagrams. You have to make sure friction ka directions also. Do you guys remember how do we decide the direction of friction? Assume there is no friction. Then can tell me which block will go outside. If there's no friction anywhere, how will the blocks move? Who has more centrifugal force? The 2m, isn't it? So 2m will try to come outside. So m will try to go inside. Then now you know how they would have gone if there is no friction. So based on that, you have to apply the direction of friction. Be careful. You cannot take the direction of friction whatever you want. You have to decide the direction of friction before drawing an FPD. If you choose whatever you want, you will get wrong answers. Friction has that problem. You have to first figure out how the bodies would have moved if the friction was not there, and then apply friction to stop that relative motion. The friction ka direction has to be decided. You can't assume any random direction. So here we can clearly see if there is no friction, the centrifugal force on 2m is more than m, so that would have gone out. Try everyone. Let's see. So if I draw these two things separately, first thing, the centrifugal forces would have been this way, 2m omega square r. This also will be outward m omega square r. So we can clearly see here that 2m has more centrifugal force. So it would try to go away from the center. So 2m is trying to go away from the center. That means there is one friction on the ground, F1. There is one more friction here, F2. So please check your FBD. And there is one tension here. Hope you have taken all these forces. And if this is F2 here, this would be your tension and this would be your F2. Check. Most people mess up the FBD. Once you got this, you're done. So tension will be equal to F2 plus m omega square r. And here F1 plus F2 plus tension is equal to 2m omega square r. Substitute tension here. We get F1 plus 2F2 plus m omega square r is 2m omega square r. F1 is nothing but the friction on the ground. So you should take this N1, which is mu into 3 mg. F2 will depend only on that mg. So 2 into mu mg is equal to m omega square r. So this guy would be 5 mu g by r is omega square. So that's just a root. Check. T is not given, Revojas. Clear with this? Next thing. Clear? There. So with that, we are done with the part of it. So next class when we catch up, we'll continue to do more problems. We'll do few more varieties here, and then we'll do something called banking of roots. So that is one. So yep, that will wrap up for the day. We will see the paper cut outs and